All right, so I think we're live. Welcome. Sorry. Welcome everyone to the week 2 Q&A session that we're going to have. Just disable the sound. Yeah. So at this point, you should be fairly familiar with the current week's task related to serverless S3. Um, so just let's take a quick look just to make sure that everyone's on board what we're doing here. So as per agenda, this Q&A session will be dedicated to reviewing the necessary knowledge that you need to have at this point um, in order to successfully transition to the next task. We won't be reviewing any homework material per se, meaning that the task won't be discussed, but we're going to cover most of the theoretical knowledge that, yeah, again, you will need to have in order to transition. So the goal of the week was to learn about SPAs, or what they're all about, how to serve SPA, what does it mean to serve an SPA or host an SPA, the different hosting concepts or related hosting concepts like object storage, CDNs, um, cloud storage services maybe, and in particular hosting via AWS S3 service. The topics should be fairly straightforward in order to cover the entirety of hosting with AWS using S3. So that is, what is a S3 as a service? What is CloudFront as an AWS service? How do we go about deploying something to AWS in general? And how are we deploying something to S3? Um, then what it is to have a serverless framework in the project, meaning that what it actually is as a technology, and as well as how is that related to AWS as a cloud and AWS as a CLI tool to access AWS cloud. So in the materials you were presented with a number of lectures, short videos describing each of the steps. So these are must watch. And in additional, there were a number of things that were covering S3 as an entire service, but without the any kind of oversight into what you need to be doing or what you need to know at this point. So let's quickly go through the main areas. And I would like to start with an SPA. SPA, you might know, that's just a bunch of JavaScript code that actually executes on client side and is able to deliver some content. An example of SPA would be something that comes out of React, Angular, or Vue. So when we build them. So if I were a student learning about cloud development within this program, at some point I would fork one of these repos, the JS Competency Center for Vue, React, or Angular. So let's take a look at one of the repos. Okay. For example, this repo at some point will be able to be built using some kind of process, and then what ends up as a build artifact we will be deploying somewhere, and that number of files will be serving something to the end users. In our case, a build artifact would be a bunch of files that are just raw HTML, CSS, and JavaScript. There's no actual API or nothing like a server that needs to be running constantly like a process in order to serve that. So it's just a number of static files. And in order to serve just a number of static files, there were a number of technologies invented throughout the years. Um, One of them you might be familiar with is Nginx. And if we just quickly Google that, it's a web server. So that's a key point to understand in order to proceed, is that there is a clear distinction between a web server and an application server. And one of the common questions in any interview session, what is the actual difference? So this is what we say when we face with that question, meaning that web server is actually the one that serves static content. As we just mentioned, static content is the artifacts that are getting built when we run certain scripts with React, Angular, Vue. So using a web server, we're able to serve that request, those content or those artifacts. With an application server, application is usually considered to be an API. And one of the next tasks would be related to not just serving an SPA, but serving an actual API. The reason I'm doing kind of a dedicated focus currently on SPA and API and the differences between web server and application server is key, because when it comes to serving web content, that static content is generally the same among various different providers, various different projects. So if I build a number of HTML, CSS, and JavaScript files, and you build like your set of HTML, JavaScript, and CSS files, the way that we serve them will remain the same. So that means there's no actual difference in what kind of process needs to be running somewhere to serve those files. The content of the files will differ, but the actual way of serving them will be the same. And that's why we have Nginx or any web server. It's just a process. You set it up on somewhere, on some machine, and then that machine will be waiting for you to upload those files to be able to serve them. So going back to our example, if we build React application and get those HTML, CSS, and JavaScript, we just need to upload them somewhere, and that's how we are going to serve them. If you think about it, GitHub allows you to do exactly that when you use GitHub Pages. For example, let's not go there. Let's, for example, go here. There will be an environment, and that environment includes GitHub Pages. And if I were to click on that page, I would actually get to the number of deployments that I'm doing at no cost. It's just what GitHub provides. And suddenly I'm able to access seemingly a website. What's happening behind the scenes exactly is that on my repo I have a specific branch, or I used to have a specific branch. I think it's now serving master branch, but in any case that branch would have, for example, a build folder with all the artifacts, HTML, CSS, and that's exactly what GitHub will get from my repo. Without me launching any server, the GitHub will get those files and do the web server related things. So The theory behind SPAs is that you don't need a server. It's just a single page application. Single page meaning that no matter where I go in that application, changing URL does not result in change of the actual HTML, CSS, and JavaScript returned from the server. I don't do any requests from the server. They are static. I already got everything that I need just by, as I mentioned, just by storing them in somewhere. In this case, GitHub web server um, place. And yeah, that's it. In case of a multi-page application, I actually need to store multiple pages, and that usually is done with the same setup that I have at the moment with just the static content. But most of the application, they also have some kind of integration with API, which will require the actual compute power, meaning the actual PC to run that process and respond to the incoming requests. And that's a fairly bit more complex in terms of resources that you need if you want to have that dynamic content. For static content, again, you just need a web server, not an application server. So that's covering the first part of the theory behind this current week task. Um, Next, we have object storage, CDNs, etc., etc. So it's a direct continuation of the theory behind SPAs. If you look closely at this link, it's pointing to GitHub, GitHub IO. It has some kind of subdomain. Usually, if you serve using GitHub Pages, it's your name of your account. That is a subdomain, but by which you're serving the actual GitHub IO. And I believe this one won't work. Yep. But in any case, they are somehow doing really nice job delivering content for me. It's pretty quick, even regardless that I have lots of stuff going on, probably for other projects, not this one. It's just flip the sheet. But if you take a look at the number of seconds it gets, or number of milliseconds, or seconds, yeah, in my case, it's a 2-second request. It's not really much in terms of if I were to suddenly relocate to another part of the world, I will still get roughly the same amount of seconds, um, which is nice because this GitHub repo is actually information somewhere on the internet, on one of those GitHub servers somewhere, inside a web server on GitHub side of things. So it's an actual physical place, and I'm seemingly getting the same results in terms of speed, no matter where I am in the world. And that's exactly why we need CDNs. So CDNs are content delivery network, and if we were to Google just an image to be on the background while I talk, yeah, this one is really nice, or even this one. So it's just see. Oh no, it doesn't look right. Yeah, this one is a bit better. So this one is what CDN looks like. No matter where I am in the world, I'm seemingly getting the same result in terms of speed of which my content, web content or API content, any content that is somewhere in the server is getting back to me if I request one. If there was just one or just even a couple of GitHub servers in one place, for example, somewhere in Central Europe, if I were to relocate somewhere to North America or to the South America, or even somewhere like below the Cape Town in Africa, I would probably get a very different results. That's probably not the best user experience, so we created back in the days a concept of CDNs. And what CDN is that the original server copies the entirety of the content that it needs to deliver faster to some of the closer servers. They're called edge servers, or in AWS terms, they are called edge locations. And this way, even if I'm not really aware of that edge server existence, I'm still accessing seemingly original server. Those edge servers are able to proxy my request, or I should say, kind of mm, somewhere at the DNS level, intercept my request and send back the content that they have instead of the original server. And since that's the the copy of the entire thing, I get faster results without actually getting all the way to the original server. So that's the entire purpose of content delivery network. So network of kind of servers that deliver best possible results to the closest users in terms of content. Sounds like caching, and it is part of how we do caching on the architecture level side of things, and it's one of the best solutions for front-end performance or caching performance, network performance for front-end engineers to know about. So content delivery network is a way to go. And there are a bunch of them. Cloudflare is one of them. Amazon has a service dedicated entirely to content delivery network, which is called CloudFront. So that's covering this one and this one. Since we are in AWS, I can't rely on AWS or on GitHub to serve my web content. I need some kind of web server on AWS that will be able to serve the same purpose that GitHub pages do in GitHub. And for that, we are utilizing something called an object storage. So in AWS, there is a object storage service that is able to store files, just raw files, and then serve them in one way or the other. One of the serving ways or methods to serve those files is using a web server. So presumably, an object storage is just a place in AWS Cloud that is able to store not a structured data like we have with databases. It won't be a JSON data. It won't be some kind of I don't know, table data. So, but it's still a data. It's just in the form of files, and that's one of the many ways to store data as is in computer science. You will learn about databases, which is a way of storing not files but actual data itself, like bits and information. Um, but we'll start with S3 as an object storage. You might also encounter um, terms like blob storage or object storage, as we just mentioned, or just storage or file storage. That could mean almost the same thing. There are technical differences between these terms, but all they mean is that the data is stored not in some superficial tables or documents as with Mongo or Postgres. Data is stored as objects. That could be files, that could be like all the different files, I mean, all different extensions, as well as raw binary, which doesn't really have any extensions, just binary data. And we do that type of aggregation of data for various different purposes again, to streamline uh, storage of files and facilitate hosting of static content, or just store something in the cloud like a Google Drive, or maybe, I don't know, um, what they have in terms of data as a software, as a service, C. So it should be data as a service. Let's see what they have. Actually, actually forgot all the names suddenly. So data as a service is essentially what you do have when you have something like Google Drive. Just Google GCP, Google Cloud have their own stuff, okay. But in any case, those storages, like Google Drive storage, is your online storage. So you can think of S3 as the same type of thing as Google Drive. Yeah, OneDrive also for Microsoft services. And that's covering object storage. And now we're at the point where we need to discuss S3 in some more details and make sure that you understand the difference between CloudFront and S3 and what roles are they playing at this point. But in order to do that, I'll first check the questions if we do have any. So guys, if you do have any questions, feel free to ask. Okay, so since there are no questions, let's make sure that we understand what are the different services in AWS we need to know about and how they're related to each other. So let's go to the Cloud Console Management Console in AWS. Let's see CloudFront. Okay, so it's a global content delivery network, so that's already a sign of we're getting somewhere. Okay. Okay, so we have a fair bit of buckets already inside. So this is how we see S3 as a service. So it's a store and retrieve any amount of information of data from anywhere. That's exactly what we just discussed. So raw data, data objects, blobs of data, so binary data as well. So think of it as your Google Drive. And CloudFront is a secure delivery content network with low latency and works exactly as I described in terms of features. Let's see if they provide any documentation on that, but I'm sure you've already read all the related documentation. So in order for us to go further into details, the only thing that you need to know at this point are distributions in CloudFront and buckets in a Amazon S3. So presumably, in order for you to create stuff in S3, you create a bucket and bucket is exactly what it sounds like. It's a folder, presumably, that you'll have kind of access to with various different permissions, and you store some data inside of that bucket. So let's have a temp bucket. North Virginia, no, shall I disabled? Okay, block all public access. Yeah, let's disable that for a moment. Because yeah, presumably I know what I'm doing. Let's add a tag called name. It will be temp, so that we can trace it at some point. Any advanced settings? Object lock? No. Let's create a bucket. Bucket name must be unique. Yeah, exactly. It's one of the errors that you might get during your implementation. Bucket names, since they are essentially web servers and they will have some kind of rules to serve your files, they will need some kind of randomization. Let's call it AWS, and Node.js and AWS, Node.js and AWS temp bucket. That should be unique enough. No, really? Okay, Q222. Bucket name contain. Oh yeah. And this are not permitted characters because, again, exactly that I mentioned before, web serving of static content is the way for us to go. So bucket name mustn't go. Oh, come on. It's always frustrating to do that. I don't remember the rules per se. It's impossible to remember if you work with AWS, I guess. So create buckets. Yeah, what do you need? So acknowledge that will be public. Hopefully no one's going to use that bucket without my permission. So this bucket is created, and if I place any object inside and do some magic to point in the correct distribution, for example, I think it should be in management. Okay, properties. Let's see. Login events, transfer object log, static website hosting. Exactly that. Enable will need to point it to an index.js, index.html. And we'll need some kind of index HTML there already. So if you were to create this entire thing and access it, the properties of the bucket, you'll be able to serve that exactly like we have here. Since it requires some of the setup, I don't think there will be enough time for us to completely do that. But in any case, that object, that index.html, is exactly what we need to have an actual SPA served. So once you build an SPA, you place it in your S3 bucket with necessary properties set up in terms of static hosting at the bottom of properties. And once you enable that, you will have an actual URL that you'll be able to access the bucket, the content inside of the bucket. But while I'm here, let's quickly go back and delete the bucket because I realize I don't need it. It's not empty. Come on. Oh yeah, thank you. Just a sec. There's an annoying thing in AWS when you can't delete a bucket before you. Okay, okay, I was trying to delete a different one. Come on. So, okay, with bucket, we will have a then once we have everything in the bucket, we will create a distribution, and distribution is nothing more than a logical resource somewhere in AWS that says, hey, I would need to have a certain edge locations populated with my stuff, and you will point that stuff, you will point the distribution to S3 bucket as a source of all the information that you need to be at the edge location. It will take some time in order to propagate the changes, just because physically those files from your S3 bucket need to be delivered to the content delivery network some shape or form. And once you start receiving requests from the edge locations that you create here, those content will be cached at that edge location, and whenever you access, whenever users access that edge location, they will have the content without the need to actually go to your S3 bucket, which is, if you take a look at any of the bucket, you'll have an actual region that it's stored into. So going back again to the way that regions work with AWS, and the CDN, the need to have a CDN, you realize that CDN will actually help you to propagate all the content. So that's the link, and that's what we need to cover this CloudFront and S3 um, theory. So the reasoning why we have CloudFront again, we need to have a faster delivery time and to actually, and there are various different other features that CloudFront provides, but one of the main reasons is to have that faster delivery time, so it acts like a CDN. You also can have a mention of CloudFront being the way to have a public URL, publicly accessible URL, but the setup that you will require to have a publicly accessible URL with CloudFront could be additionally configured to have a Route 53, and Route 53 is one of the services in AWS that allows you to further control DNS, so it's scalable DNS and domain name registration. So, and you will have Route 53 if you were to have something prettier than just a number of random characters, like you do with Heroku, or like you will have if you were to serve one of the um, buckets. So if you don't want to see this in your URL, um, and you want a more human readable thing, you will have a Route 53 record, and you'll have that Route 53 record using CloudFront as a distribution of your content. So Route 53 will point to the distribution, and distribution in turn will point to your S3 bucket. There are a number of considerations that you need to take into account when you do that. The details are in the documentation and the video content that we have. Um, Mainly, the one that you need to think about is you don't need to have random people accessing your stuff, basically. And by the way, let's empty what I have here because it's public and I don't really want people to access it. Permanently delete. That's what you typically do in S3 is go around and delete stuff to make sure that you don't have anything or anyone accessing it without your permission. And what is handy about S3 and S3 being in one of the oldest services in AWS, historically it was really hard to control its access permissions, and that's why you have various different levels of access permission, like um, access control lists, or maybe bucket permissions that I just disabled when I was creating new bucket, and that's all a part. Um, um, Besides the fact that you actually have a dedicated service to control access, meaning in user um, IAM IAM service, yeah. And yeah, historically, that's the reason that we have lots of different places to do that. Okay, so let me just finish deleting this bucket that I was creating before the lecture. Okay, so and finally, serverless framework and CLI. So if you were to do the setup that we are suggesting, you'll end up using some kind of deployment tools and deployment scripts, and some of the package JSON might be of help to you. Some might not be enough, and you will have to figure out yourself. But overall, you will end up with some kind of serverless.yaml file in your repo, and that would contain the minimum amount of stuff that your um, infrastructure needs. But what is a serverless framework? So if you were to go to serverless.com website, it will probably be a bit more confusing than it actually is. It will say like it's all in deployment monitoring for AWS scaling up on AWS Lambda and blah blah blah, and etc. etc. Um, in regards to serverless, there are a bunch of services in AWS that are indeed serverless. AWS Lambda is one of them, but it's just one. Um, an example of a serverless service in AWS is, for example, DynamoDB. If I were to correctly type the name, DynamoDB. And the reason I'm saying that it's a serverless, or could be considered serverless, because you don't actually deploy it. You see, that's a managed service or managed database. So you just create that DynamoDB, for example, table, and you just access it using URL. You don't host your database. You don't have access to any of the underlying stuff of that database. And Dynamo is really fast in terms of how you um, access it, and that's because of its serverless nature from your perspective as a user. So serverless is all about that. So it's not only on the AWS Lambda, for example. And we have a bunch of other services going forward with our program. One of them is SQS, um, simple queue service, also managed service. So whenever you see this word managed, you can think of this thing as a serverless service in the sense that you don't actually control much of the stuff under the hood. So RDS is um, managed, but yeah, you need to be careful about that. It's not really serverless. It's partially serverless, but again, it defeats the purpose of being serverless. If you choose the region, if you do through deployment, etc., etc. So going back to serverless, again, all in deployment and monitoring for auto-scaling apps. That's not helpful, and that's why I want to kind of make a quick stop here and discuss infrastructure as code. You probably seen that a couple of times. So infrastructure as code is a collective term for various different types of things that we do, not necessarily with AWS, but with any cloud, with any infrastructure. It could be even not cloud related, or it could be on premise. So as you can see, various different tools are called platforms as a service and infrastructure as code. And there's no mention of serverless framework here, but we do see that it mentions AWS CloudFormation, and serverless under the hood is actually exactly that. So for those who are not familiar with AWS CloudFormation yet, let's quickly have a small demo. CloudFormation is a service that creates and manages resources with templates. A bit misleading. Those templates are exactly what we mean when we say infrastructure as code. So you have some kind of way of writing code in your. Let me just quickly go through it here. So you have some way of writing code in your GitHub, for example, and storing that in GitHub, and then using CloudFormation, you will be able to take that code and deploy the actual resources. So it's a resource management tool, and serverless framework under the hood, it creates CloudFormation resources. So if I were to go back to this, I was trying to come up with a way to authenticate, but it didn't work well, so I had to delete that user. And in any case, it's an example application straight from creators of serverless. And if we were to look at the code, it's a simple YAML file. It defines some of the properties, some of the function, etc., etc. and at some point you deploy this code, and you usually do that with a bunch of commands. For example, I already have serverless framework installed in my machine. If I were to, for example, say serverless version, yeah, nvm use 16.14.1. Serverless version will give me an actual version that I'm currently using in my machine. Let's see. Come on. Serverless version. So yeah, because of the recording, I'm getting a very slow output. Yeah, but it's actually saying that a version was not found because it should be this way. Come on. Yeah, so serverless is installed, and that's how you check if something is installed. And then if you want to actually deploy stuff, you would actually say deploy, and it will go ahead and do stuff with these files. Let's see if I actually finished setup. That I will delete probably because I just licked my credentials. So if I were to look at what we have here, it will probably say, oh, you detect and recognize the large profile. Oh, come on. How do you specify the profiles? Serverless profile. Yeah, blah, blah, blah. Serverless deploy would actually export that, config credentials, provider, yes, yes. How do I say which profile I'm using? Deploy particular profile. Let's see. Oh, it's AWS profile. Oh, come on. Okay, work. Okay, it's packaging. Cool. So while it's doing its thing, one of the operations that you noticed just appeared was creating CloudFormation stack. What it means is that under the hood, serverless is actually using AWS CloudFormation to deploy stuff. So that's how you end up using actual infrastructure as code. And besides just doing deploy to actually see that CloudFormation stack creation, I can go in the console. I can go to the actual AWS console, and if I were to go to the stacks to the correct region, which is US East, is it? US West, US West 1. I'm deploying to US West 1 for some reason. That's because of the default region that I didn't specify. And actually seeing stuff being deployed. So stacks are just a logical collection of things. It's for the purposes of actually updating things, and I think it will fail because I just noticed that I need to provide the bucket name, which I didn't provide. but that's okay. Uh, when the stack's creation is in progress, oh, it's actually deployed. Really cool. So you'll see all the various different events, and this is for debugging purposes and also resources that this stack will be creating. So let's see what it created. It created the rule for my Lambda, the actual Lambda, a lock group for that Lambda, and it actually went and created the deployment bucket. Okay, so this was actually optional. And yeah, seemingly from this much of actual code, which is not that much, I was able to create all these files. And that's because that's actually the reason to have a serverless framework, is to kind of have an abstraction and an easier time to focus on the actual code of your Lambda functions or buckets, or presumably mostly Lambda functions, instead of writing infrastructure as code per se, which could be a lot. If I were to, instead of do deploy, do something like, um, let's see, package, you see that we currently have this file folder already, but if I were to just package, this command usually does, and by the way, there is a way to run SLS package, which is a shorter form for serverless. Um, what we actually do, it will read the serverless YAML file. It would do the magic behind the scenes and would come up with all the necessary um, stuff, um, without actually deploying any resources, and will create those uh, JSON files for templates. So CloudFormation template creation stack. It will have a bunch of resources under here, and it usually corresponds to the service that we see there. So serverless deployment bucket, um, or let's find one of the resources that we have. Save Lambda function. If I were to copy this logical ID, which usually corresponds to the resource key. Um, okay, it's not here. Let's see what it actually does. Oh, so, come on. Yeah, this is the actual stuff. So it's just for the CloudFormation things, and serverless state is for our resources. So this is the actual function. It will do all that. So a lot of code that we would otherwise had to write ourselves. So 300 lines compared to just 20, 27 lines. So that's the rule of the serverless framework in our case. So, and that's that. If I were to delete, let's see what SLS says about that. So help, let's see what it says. How do I delete what I just deployed from my CLI tool? Install, create, dashboard, plugin, test, remove. Remove serverless, yeah. And again, that command should probably be using my AWS profile, SLS, remove. It will look for the file serverless.yaml because I'm executing this script from the root directory. It will look at this file, or will regenerate the serverless and look at the stuff that we need to have deleted in our AWS profile or AWS um, account. It's actually in the process of removing stuff. We can go back to confirmation and delete in progress. And if I were to stay here and look for the actual progress, at some point it will say that it deleted the entirety of thing. And yeah, there are no stacks, nothing at all left here. And it will say we successfully removed all the resources. So without going into too much of the task itself, I just showcased to you various different things that you need to know and be able to do, which is um, create a bucket, place something in the bucket, make that bucket a web server by changing its properties, then create a CloudFront distribution, point that distribution back to your bucket in order to read the contents and deliver that to various edge locations. And you do all that just by using Serverless Framework infrastructure as code, which is under the hood, as we just saw, um, just a bunch of CloudFormation files. So I hope that was helpful. Let me see if I have any questions at this point. So Mitri, could you please tell what backend repo should we use in assignment 3? Okay, so let's take a look at assignment 3 then. So if I were to go here, okay, okay. So backend repo, I assume it's actually part of your task. So it's a create your own public GitHub repo for all future backend work. So that's exactly what you need to do. There are no given things because we actually, like the reason why we're giving you front-end repo is that this program is more about AWS and Node.js as opposed to front-end related things. That's why front-end related stuff was already pre-written. That's why we have these like number of stuff in here already. And yeah, hopefully that's enough answer for you. Um, Sufficient answer to summarize, you need to create your own backend repo. It could be following the same naming that you have for your front-end repo, clone. So yeah. Okay, so I'm not seeing any other questions. So let me just summarize. We discussed a bunch of things. We discussed a bunch of options of like creating services, CloudFront and S3 services and resources in them to serve various different purposes. You will find that as infrastructure as code in your example of one of the repos. So buckets that have website configuration that actually enable you to have that serving web server type of operation of S3. You will have actual distribution that points back to the S3 bucket in order to have correct service. It will point to the correct file. It will allow some of the caching behavior and do a bunch of high-level stuff, but the output will be that you will be able to serve your SPAs, and the rest is up to you. The rest will be done in the backend repo, but in the same fashion, using serverless, using various different AWS lambdas, and following the next task, probably using AWS API Gateway. So, and that's that. So, thank you for your attention. I hope that was helpful for anyone who's watching live or will be watching or rewatching this lecture in the future. And yeah, just to summarize, don't try to use my credentials. Probably um, you'll probably won't be able to do anything with them because I know what I'm doing.